again, just review. We're taking our protractor. The very center point of my protractor needs to go directly over or directly above my vertex. So I line those up. Once those are lined up, now I'm getting the flat bottom edge of my protractor aligned with this flat bottom edge of my angle. Okay, so there it is. I'm going to line it up. Boom. Okay, now I'm going to hold it there as tightly as I possibly can, because everything I'm going to do now is by keeping this protractor in place. How big is this full angle right here? 30. It lines up right there. You see that 30? So this whole thing is 30 degrees. Well, what's half of 30? 15. Notice how I haven't picked up my protractor yet, right? I'm going to find 15. If this notch is 10 and this one is 20, 15's got to be right there in the middle. Notice I didn't make a big old fat dot. I just made a tiny little dot. The smaller my dot, the more precise my bisector is going to be, right? Because if I did something like, if I measured this one, let's just say I measured it right and I get 115 and then I go right here, right? And there's my dot. There's a whole different range of angles that I could go with this dot. I could go here, I could go there, I could go in the middle. The smaller the dot, the more accurate your bisector is going to be, okay? I'm going to put my pen on my vertex. I'm going to line up my straight edge. Does that look okay on number 9? Number 10, same thing. This looks like what, 60 degrees?
No.
120. This is obtuse, right? So I know I got to be looking at the top numbers here. So if this whole angle is 120, half of that is 60. Now I can move this over, line it up, boom. Right? So on the test that we're taking next, probably Wednesday, I told you yesterday, I'm going to be sitting at these tests with a protractor measuring. If you are 1 degree off, it is incorrect. Okay, this is a very precise work. I was telling someone over here, if these are the blueprints to a house and you're an engineer and you're drawing them and they're not precise, and then they go and build the house and the walls don't close because your measurements are off, that's all coming back to you because you're the one that made the blueprints, right? So when obviously this is a much less, I'm not going to say important, but you know what I mean. The stakes are a lot lower. We're just doing a worksheet. We're just taking a math test. But what we're learning here is precision. How accurate can we get it? So if I put my protractor on yours, right, on the test, and it's supposed to be lined up at 60 and you're lined up at like 59, right, that technically is not a bisector. Bisectors cut it in half. So if one of them is 59 and one of them is 61, is that cut in half? No. Okay? So the important thing with this is taking your time, really being solid, and just paying close attention. I know some of you guys just like to breeze through work and go by super fast. When your goal is precision, you have to take your time. You cannot just breeze through it. That's how you're going to make mistakes. Okay? Any questions about that? Perfect.